On February 27, 2026, a single image was released to the public that changed the way we look at our own neighborhood in space. This image was taken by ESA's JANUS spacecraft, a probe that is flying through deep space right now on its way to Jupiter. What you're looking at in that photograph doesn't belong here. This is 3I Atlas, an object that spent millions, maybe billions of years traveling from another star system entirely. This is the first time in the history of human exploration that a spacecraft has ever photographed an interstellar visitor up close. Think about that for a second. In all of human history, we have only ever confirmed 3 objects entering our solar system from the vast emptiness between the stars. Just 3. And until Friday, nobody had ever done what JANUS just did, point its high-resolution camera directly at one of them from inside the deep trenches of space. JANUS stands for Jupiter Icy Moons Explorer. Its whole job is to get to Jupiter and spend years looking at Ganymede, Europa, and Callisto to see if their underground oceans could hold life. That's the mission. But the people running space agencies are incredibly smart with the tools they have. While JANUS was just cruising through the inner solar system, mission planners saw a golden opportunity. They realized they could turn the calibrated science camera toward this interstellar visitor and see what they could find. So, back on November 6, 2025, JANUS did exactly that. It performed a maneuver, aimed its JANUS camera, and snapped a series of exposures that were finally beamed back to us after months of waiting. The reason we had to wait until now to see these images is almost as cool as the science itself. For the last several months, JANUS was effectively hiding behind the sun from our perspective here on Earth. When a spacecraft is in that position, it has to use its massive high-gain antenna as a giant umbrella to shield its delicate parts from the sun's heat. That meant it couldn't talk to us very fast. It had to send this data back bit by bit through a tiny medium-gain antenna, like trying to download a movie over a dial-up connection from 60 million miles away. But now that the full data set is here, we can see why it was worth every second of that wait. What makes this special isn't just that it's a pretty picture, it's the vantage point. JANUS was only 0.44 astronomical units away from 3I Atlas. To put that in simple terms, it was less than half the distance between the Earth and the Sun. That is incredibly close. It's a distance that Earth-based telescopes can't replicate, and because JANUS is in the vacuum of space, there is no atmosphere to blur the view. No clouds, no light pollution, just raw, perfect data from another world. So, when the scientists opened these files on Friday, what did they actually see? 3 things jumped out immediately. First, there is a bright central condensation. That's the nucleus, the hard mountain at the center of the object where everything is held together. Second, there is a diffuse surrounding envelope, which is basically a big, glowing haze of material. This tells us the object is active. It's alive and breathing out gas and dust as the sun heats it up. Third, there is an extended dust feature, a tail, and it's perfectly aligned in the anti-solar direction. That means the tail is pointing exactly away from the sun, just like you'd expect from a comet being blown back by solar wind. But this is where it gets really interesting for the people who study physics. When you look at a comet from Earth, your perspective is flat. You're looking through the soup of our atmosphere and seeing everything from one fixed angle. You miss the tiny details of how the dust is moving. JANUS, however, was looking at 3I Atlas from a completely different side. It was able to measure what they call scattering angles. By looking at how the sunlight bounces off those dust particles from a different side, we can finally figure out how big those particles are and how fast they're being kicked off the surface. It's like being able to walk around a sculpture instead of just looking at a photo of it. We can see if the activity is symmetrical, or if it's only coming out of one side. Now, I know it's on everyone's mind. Ever since Oumuamua showed up in 2017 and did that weird extra speed maneuver that nobody could quite explain, everyone has been asking, is this one a spaceship? Is it a probe? If you listen to the official reports from the team that released the image, they'll tell you that the physics holds up. They say that what JANUS captured shows structured outgassing that is completely consistent with a natural comet. It's a ball of ice and rock. It's getting closer to the heat, and it's sublimating, turning straight from solid to gas. everything about the way it reflects light and drops dust looks like nature at work. But not everyone is ready to close the book on that just yet. Professor Avi Loeb from Harvard has been looking at the exact same data, and he's pointing out some things that are, frankly, a little weird. He's looking at what he calls anti-sun jets. Usually, a comet sprays material toward the sun because that's where the heat is hitting the ice. But in the JUICE images, Loeb sees jets firing off from the night side of the object, the side that should be cold and dark. He's also looking at the chemical fingerprint of this thing. The Hubble and Webb telescopes found that 3I Atlas is almost 87% carbon dioxide, but only 4% water. Most comets we know are the opposite. They're mostly water. Plus, there's a really strange ratio of nickel to iron in there. Some people are saying that looks more like an industrial alloy than a random space rock. So you've got two stories happening at the same time. On one hand, you have the standard scientific view that says this is just a very weird, very rare interstellar comet that formed in a star system with a different chemical recipe than ours. On the other hand, you have the more adventurous theory that says we might be looking at a piece of technology, maybe a dead probe or a solar sail, that is using those jets-like thrusters to navigate. And because 3I Atlas is moving on a retrograde orbit, meaning it's traveling the wrong way compared to all the planets in our system, the odds of that happening naturally are only about 1 in 500. Whether it's a rock or a machine, the most exciting part of the story is actually what happens next. We are only 16 days away from the big event. On March 16, 2026, 3I Atlas is going to make its closest pass by Jupiter. This is going to be the ultimate polygraph test for the object. Jupiter is so massive that its gravity acts like a giant scale. As 3I Atlas flies past, Jupiter is going to tug on it. If it's a solid, heavy rock, it will follow one path. If it's hollow or made of very light, thin materials like a sail, it will be pulled much more easily. We have the Juno spacecraft already orbiting Jupiter, and it's going to be listening with its radio instruments for any strange signals or magnetic interference as the object passes. Every interstellar object we find is a message in a bottle from a place we will never reach in our lifetimes. 3I Atlas came from a star we might not even be able to see with our naked eyes. It traveled through the total darkness of the void for millions of years just to end up here, right when we finally have the technology to meet it with a camera. We are currently living through a moment where we are looking at the most detailed data ever collected from a piece of another world. Whatever the Jupiter flyby reveals in 2 weeks, the images JUICE gave us on February 27th have already earned their place in the history books. We aren't just guessing anymore. We're out there, we're watching, and for the first time, we have a front row seat to a visitor from the stars.